Okay, so we're going to finish up section 8.5 looking at margin of error, which is the title of the section, and its calculation. So margin of error gives the maximum expected difference between the sample result and the population parameter. So we looked at, in the first half of this lesson, finding that 95% reasonable range. And ultimately, when we're looking at that visually, notice that it's really just cutting off the last two values if we have a histogram, right? So I'm ignoring the last two small peaks, and then the numbers that fit within that are what we call that 95% reasonable range. So when I don't have something like this, when I just have a set of data, I can find that margin of error in different ways. So it depends on what kind of data I am given. So quantitative data, remember, quantitative data is something that is numerical, so something that I can average, I can find the mean and standard deviation of, versus categorical data. So I have two different equations, and I have to use them depending on what type of data I have. So categorical data is literally just yes or no questions, that kind of thing, where I'm answering with the word. So that's the first question we have to ask ourselves, is what kind of data is this? One of the key clues as to what kind of data you have is if they give you a standard deviation, that means that it's quantitative. So they aren't gonna, you cannot find standard deviation if you have just a list of answers. So for example 4, we're going to calculate some of these margins of error. So the College Board recently reported that the mean score on the SAT math exam is 508 with a standard deviation of 121. Washington High believes that its seniors score considerably higher than the national average, so the schools randomly sampled scores from 200 seniors, finding a mean score of 550. Is Washington High correct in its belief? So let's talk about how we can answer this question. So if they are reasonable, then because they're saying that they're significantly better, that would mean that their results, their average, lies outside of that reasonable range for means. And so when we're finding this reasonable range, and I'm working with margin of error, that reasonable range is going to be between the mean of the data. So this is my actual mean score on the SAT, plus or minus the margin of error. So in our case, either one of these, right? So that's going to give us the reasonable range for the mean in this question. So what we're looking at is that we have a mean of all the people that took the SAT in whatever year this was collected for the math as a 508 score. The standard deviation is 121. And so what Washington High did is they took a sample of 200 seniors. So sample size, we're told, is the number n in this formula. And they found that their mean score, so we haven't used this yet, but we kind of talked about it. So because this is the sample, we're going to use X bar for that. So we talked about what X bar was when we introduced the notation for mean. But we were always talking about population mean, so we used mu. So X bar is 550. And so what we're doing is we're going to find this reasonable range by calculating the margin of error. So I talked about already that if standard deviation is included in the problem, then you're going to use the formula with standard deviation in it. If it doesn't say anything about standard deviation, that means that you have categorical data, and you're going to use the formula for that margin of error. So since I have a standard deviation, that tells me that I have quantitative data. But I can think about that as if I'm finding a score, right? A score is numerical. So the margin of error is equal to 2 times the standard deviation divided by the square root of the sample size. So 2 times 121 divided by the square root of 200. And so if I calculate that out, 2 times 121 divided by the square root of 200, that gives me a margin of error of about 17.1. So what I want to look at then is what is the reasonable range of means. So reasonable values would be the population mean, which is 508, plus and minus my margin of error, which is 17.1. So that means I'm going to take 508 minus 17.1, which is, oh, I use 17, well, whatever, which is 490.9, and then 508 plus 17.1, which is 525.1. Okay, so that means that a reasonable set of values would be between those two numbers. So the reasonable would be between 490.9 and 525.1. Since this number, 550, so since 550 is greater than the reasonable range of means, Washington High School is correct that their seniors did much better. Okay, so we had to calculate the margin of error for quantitative data, then add and subtract that number from the true mean of the population, so what College Board said that the mean of that year's data was, and then compare, is Washington's score between those two numbers, or is it outside of those numbers? Did they actually perform better than where the true average lies? So remember, this reasonable range means that an average that is close to that would be land anywhere between 490 and 525, that would be a true statement that they're close within the average. For part B, we have a random sample of Washington High seniors that reveals that 40% of them plan to take the SAT this year. So this is a yes or no question. Do you plan on taking the SAT? Yes or no? So we're using the margin of error to predict the actual proportion of seniors planning to take the exam. So remember that since they're asking us whether we plan to take, that's a yes or no question. So this is categorical. Again, there's no mention of standard deviation. That's another hint that we're looking at categorical data. So all that we really need to know for this is the sample size. So it's a sample of 100. So N is 100 for this situation. They're giving us their data. So the 40% of them plan to take the SAT. This is a proportion. So this is P is 40%. And so what we're going to look at is what is the true proportion. So if I add and subtract the margin of error, that'll give me a better indicator as to where the true population's proportion lies. So since we're looking at a categorical question, we're going to use the other formula, which is just 1 over the square root of n. So our sample size is 100. So the margin of error is 1 over the square root of 100, which is 1/10 or 0.1. Since this is given to us as a percent, let's say that that is 10% then. Okay. So the same way that we did with the last problem, we're going to add and subtract this value from the value that we were given as the representation of the true proportion. So the true proportion it will be between that 40% plus or minus that 10%, which is 40 minus 10% is 30%, and 40 plus 10% is 50%. So the true population should be between 30% and 50%. Okay, so in example A, a poll reports that 25% of voters in the city want a stop sign placed at a particular intersection. The poll reports a margin of error of plus or minus 3%. Estimate the number of voters in the poll. So they're giving us the proportion, which is 25%, right? So the proportion is 25%. That was the result of the poll. And they also give us the margin of error. So the margin of error is plus or minus 3%. So that's about 0.03. So the margin of error is 0.03. Since this is a yes or no question, right, this is categorical. So do you want something? So this again is a categorical question variable. So we're going to use that same margin of error formula again. So the margin of error is equal to 1 over the square root of the number of voters in this case. So we know that m is 0.03, so we're going to plug in 0.03 for m and then use that to solve for n. So 0.03 is about equal to 1 over the square root of n. Since I have one side as a fraction, I want to think about this other side as a fraction too. So if I were to cross multiply this, that'll give me 0.03 times the square root of n is equal to 1 times 1, so just 1. So then I would have to divide both sides by 0.03. So the square root of n is about 33.3. That's really repeating. So then to get n by itself, I would have to square both sides. So n is about, if I square this, I get a bunch of 1s. So that means that about 1,111 voters participated in the poll.